Welcome back to my YouTube channel. Today I will solve a question of a JAM exams. Okay. Question is given that M is a 4 cos 3 real matrix. Okay. And E1, E2 dot En and E1, E2, E3 be a standard basis of R3. Then which of the following is true? Okay. Now solution. Okay. First option. Rank of M is equal to 1. Okay. We choose M equal to matrix 0 0 0 0 1 0 0 0 0 0 0 0. Okay, this is a 4 cos 3 matrix with rank 1. Okay, now multiplying E1 are here given E1 E2 E3 are standard basis, that is E1 equal to 1 0 0, E2 equal to 0 1 0 and E3 equal to 0 0 1. Okay, now M into E1, that is 0 0 0 0 1 0 0 0 0 0 0 0 and 1 0 0. Okay, that is equal to 0. Okay, this and this, so 0, and this is also 0 and this is also 0 0. So here one element is 0 element, and we already know that any linearly independent set does not contain a 0 element, so this is not Li. So first option is false. Okay, now second option, if rank of M equal to 2. Okay, now we choose M equal to that matrix. Here E1 and 2 multiply, so we choose 0 0 0 0 0 0 and here 1 0 0 and here 0 0 1. Okay, now this is rank of the M equal to 2. Now multiplying, sorry, we choose here 1. Okay, that is 0 and 1. Okay, now multiplying E1, so this implies M into E1 equal to 0 0 0 0 0 0 0 1 0 0 0 1 and here 1 0 0, that is equal to, this is equal to 0 and this is 0, this is also 0 and this is also 0. See again, again this is a 0 matrix, so this implies, by similarly we can say that this is not Li. Okay, because every linearly independent set does not contain 0 element. Okay, so this is also false. Similarly, same matrix choose for C, also C option is false. Okay, now D option, so answer of the question is D. Okay, now proof. Here given rank of the M equal to 3. Okay, we choose any matrix A, B, C, D, E, F, G, H, I, J, K, L. Okay, this is a 4 cross 3 matrix. Okay, and here given rank of the M equal to 3, that is, we know that we know that row rank of M equal to column rank equal to rank of the matrix A, rank of the matrix M. So that means rank of the M equal to 3, that is equal to 3. That implies M has 3 linearly independent columns. Okay, so all columns form Li set. Okay, so that is this set A, D, G, J and B, E, H, K and C, F, I, L is Li, linearly independent. Now find the element of ME and ME3. Okay, so now M equal to, that is A, B, C, D, E, F, G, H, I, J, K, L. Okay, now multiplying E1, that is 1, 0, 0. That is to A, D, here G and here G. Okay, now also multiplying M by E3. So we have A, B, C, D, E, F, G, H, I, J, K, L. Okay, and D3 0, 0, 1, that is equal to C, F, I, L. Okay, now this set A, D, G, J and C, F, I, L. This is also Li, linearly independent. Why? Because this set is linearly independent and we know that every subset of a linearly independent set also linearly independent, and this is a subset of this set. Okay, so this is also Li. So option number D is true. Okay.